Question 4, we're looking at football boots. We've got two pictures, one a boot without studs and one a boot with studs. We have a student of mass 40 kilograms using the football boots shown above. Probably not at the same time because they're both right hand or right foot boots. So you can't wear them both at the same time, or if you do, one's on the left and it's uncomfortable. Anyway, one boot without studs, this one, has a surface area of 165 centimeters square, which is given in brackets there to show you the measurement in meters squared, which is SI units, so that's probably the ones we're going to use if we're calculating anything. And that's the area in contact with the ground. And one boot with 6 studs, here we are over here, has a surface area of only 6 centimeters squared. That's a big difference from 165, and again the SI units, and that's 6 centimeters squared in contact with the ground. The question A, calculate the pressure exerted if the student stands on 1 foot, so I guess that means we only need to worry about the stats they've given us. So 1 foot on a hard surface for the boot without studs and for the boot with studs, and give an appropriate unit with that answer. Okay, so the pressure, I don't know if you've seen the formula or not, but the pressure is, let's write the formula here, pressure is given as the force per unit area. Okay, so force is measured in newtons, and the area is measured in meters squared. So in fact we've already done the units then. The units are going to be newtons per meter squared for both of these situations. Here's the second one down there. So what remains is to work out the force and then divide it by the area, because the area is given to us in both cases, although as we said we're not going to use those, we're going to use the other two in meters squared. So the force, how do we work that out? Well, we've got the mass of 40 kilograms, so we can multiply that mass by the force due to gravity or on 1 kilogram, which is 10. So F equals 40 times by 10 newtons per kilogram gives us a total force of 400. And we're going to, for the without studs one, it'll be 400 divided by 0.0165, and that gives us an answer of 24,000. So 24,000 242, and as we said before, newtons per meter squared. Okay, you could write that also as Newton meters to the -2. That's the same units. Okay, so with studs, same mass times gravity, same force, divided by the area this time of 0.0006 meters squared, and that gives us 666,667 newtons per meter squared, which is a much larger force per unit area. Okay. B. Discuss the advantage gained by the student when running on soft grass or a soft grass football field while wearing the boots with studs, compared to wearing boots of the same size without studs. In your answer you should compare the pressure exerted on the ground by the boot with the studs and the boot without studs. So we have to compare. In fact, let's do these in order A, B and C. It's nice that they lead us through this way. So A, compare the pressure exerted between the two. The one with studs has a higher pressure, the pressure is higher, okay, and without, the pressure is lower. Okay, stating the obvious, you should always state both, just to be fully clear. The next part, explain B, the relationship between surface area and pressure exerted. So in this case, the smaller the surface area, the greater the pressure exerted on the ground. Okay, so the smaller surface area, the greater the pressure exerted on the ground. And then the final part is C. You can see how this is leading you through a question, an answer. C is explain how the difference in pressures would help the student run on a softer surface like grass. Excuse me, I'll just okay, I think I'm clear. So C again, explain how the difference in pressures helps a student run. With the larger pressure on the smaller surface area, which has the studs, that allows the studs to sink into ground. And which obviously means you'll get better traction. It leads to better traction. And better traction means you can grip the ground better and run faster, turn sharper, all those sorts of things. Okay, so just making a note on how they've structured the question. They've led you through to give a full answer about discussing the advantage gained by the student when running on soft grass while wearing boots with studs compared to not. So you'd say the whole answer in one go. You'd say with studs the pressure is greater, and because with a smaller area that leads to greater pressure. That larger pressure on the smaller area with the studs leads to the studs sinking into the ground, means you get better traction compared to when you've got no studs. And here's just a quick sideways. This is not really a very good boot, but here's the studs. Okay, all of the force is concentrated through these areas where there's two side by side there, but without the studs, here's my very vague boot shape. The force is spread over so much more area, so it has the effect of not applying much force to break, and it can't break the surface of the turf. Okay.